India's leading critical minerals company focused on recycling and refining of minerals like lithium, nickel, cobalt, copper, platinum, and rare earths. At Loham, he heads government policy, investor relations, and research partnerships, helping shape India's sustainable energy future. A dual graduate, BTech and an MTech in electric engineering from IIT Kanpur, he also co-founded a tech startup, blending technology and sustainability with remarkable impact. Please join me in welcoming Mr. Pratyush Sinha to the stage for what promises to be a truly enriching session. Mr. Pratyush, all stage set for you. Thank you so much.
We'll play a short video of the session first. Thanks a lot, Gauravji, for that kind introduction. We have a very interesting session ahead of us. Before we start the session, I would like to invite all the speakers and panelists onto the stage. The first panelist that I would like to invite is Mr. Vinay Sharma. Mr. Vinay Sharma is Head of Indian Operations at GDB International, and he's also a Director at MRAI. GDB, established in 1993, essentially deals in ferrous scrap, non-ferrous scrap, paper scrap, and plastic scrap. But here, Vinay Sharma ji also leads all the lead-acid battery recycling activities. Vinay ji. Next, I would like to invite Mr. Jared Zhu, Senior Consulting Project Manager at Shanghai Metals Market. Mr. Zhu joined SMM in 2020. He has more than 5 years of experience in strategic consulting and market intelligence and served Fortune 500 companies. His focus areas are global sustainable energy market with experience in new energy value chains. Next, I would like to invite Mr. Philip Costa. He is the CEO of Rivermet. He is the Managing Director and CEO at Rivermet. He has, which is a group company of Cronimet. He holds a PhD in chemistry from Technical University of Kaiserslautern and an MBA from the University of Stellenbosch. His work focuses on sustainable resource management and scaling recycling technologies for industrial application. Last but not least, we have Mr. Pawandeep Singh Bawa, who is a Business Development Manager and Customer Success Manager at Attero Recycling. Mr. Singh is a seasoned professional in business development with over 26 years of experience across both international and domestic markets, with a strong focus on advancing sustainability and circular economy principles. And he's been with Attero since 2011 as Vice President of Sourcing, and he's played a pivotal role in driving the company's growth and expansion. Now, as part of this session, we have 3 presentations, one on battery technology, another on critical minerals, and one on battery material insights and forecast. So for the presentations, I would first like to invite Mr. Philip Costa to start. He will talk about R&D in battery and recycling and talk a bit about the work that Rivermet has been doing.
Can you go back? There you go. Thank you. So, hi. It's very nice to be here today and to talk to you a little bit about what we've been doing at Revomet, which is a 100% Cronimet company, and also tell you a little bit about the developments in the battery market and as well as in the battery recycling market and what's happening there, especially with the focus on Europe and also European regulation. So, as I mentioned, Revomet is a 100% Cronimet company. You might have seen us, we have a booth out there, and Cronimet is a family-owned business founded in 1980. Currently with more than 76, we're now 83 locations worldwide since 2 months ago, and we have one big core value, and that is for us is sustainability, because this is the guidance that we have and that follows us throughout everything that we do, and that helps us focus every day on doing what we do the best we can. Overall, if you look into Cronimet, we have a very diversified portfolio. You might know us as a typical scrap trading company. However, we don't do just recycling. We always also do trading, production, and offer services into the market so that we can really supply our partners and customers with all kinds of services and materials. And in the end, because we have such a large amount of partners and such a vast network worldwide, we are able to move material very efficiently worldwide through these partners and through these partnerships, so that we have very good logistics ways so that we can provide material from everywhere in the world. And if you look a little bit more, what does this mean for us? So last year, if you look into the results from Cronimet, we were able to sell 1.27 million tons of stainless steel scrap, and that generated an overall turnover of round about 2.6 billion euros with 1,600 employees that we have worldwide. As you know, we are a stainless steel recycling company, so the main source of revenue is always going to be stainless steel, and that's what we are known for. However, we also have 25% of our revenue comes from specialty and others, as well as 6% of processing. Now you're going to ask, well, processing, what does a scrap trader does with processing? We have a processing plant in Brazil where we produce ferrotitanium, ferrovanadium, ferromolybdenum, and other materials, so where we really go into the processing. And if you look into the others, that's where we want to focus on other recycling streams and not just on stainless steel. And that's why, if you look into what we're doing now, we entered into the battery recycling field with Revomet. So we founded Revomet in 2023, and Revomet is currently focused on the treatment of end-of-life batteries, as well as battery scraps coming from the battery production. We are trading these materials, the end-of-life batteries and the scraps, and as well as selling black mass and black powder out to the market that we produce at our location that's located in Bitterfeld-Wolfen in Germany. If you don't know it, it's fine. It's just a city 1 hour south of Berlin, very easy to find and very central in Europe. So that really allows us to leverage our network that we have in Europe to bring batteries from everywhere in Europe to Germany and recycling them there, because currently we have an installed capacity of 14,000 tons, which are operating since this year, and we are expecting to have the next stage, the 28,000 tons capacity by beginning of 2027. So that then we're going to be fully established in the market with a full capacity. And the good thing about us and the processes that we developed in the last years is that we currently have a recycling efficiency of above 95%. This is a very important point that we're going to talk about later, because in Europe we have a very stringent battery regulation nowadays and battery recycling regulation. So your processes need to be very efficient when you are going to go into recycling. And why did we decide to go into battery recycling? Well, if you look into the EV market worldwide and where it's going to be in 2050, you see that there is going to be a tremendous growth in the next years. And if you look into the growth that's going to come in the next years and the material demands that are going to come with it, this is going to be a huge challenge for the whole market, because until 2050, we're expecting just the nickel content or the nickel necessity to grow 2 times. So we have to double the amount of nickel that we have in the market right now. Until 2050, we have to double the amount, get 56 times the amount of lithium that we're using now, just to get the batteries to the market by 2050. So this poses a big challenge in the market, because we're expecting this market to grow. And we know that current political situations and current developments are slowing down the markets worldwide. However, the electrification of the vehicle fleets, that is coming and that's happening. So it might be delayed by 1 or 2 years, but this demand is going to come latest by 2050, and we need to do something about it. Why? Because in Europe currently, we are a very resource-scarce region. We have almost none of these materials and none of these elements in Europe. So all of these materials we need to basically bring from outside into Europe. And it is the European Union's goal to have a functioning battery ecosystem in Europe. So from battery production to recycling, from precursor production, battery production and recycling, all in Europe. And for this, we need to basically import all the materials from different countries all over the world. This creates some dependencies and also creates high costs, and as well as a lot of CO2 intensive logistic routes. And therefore, in Europe, we are looking for ways to become more independent on this and just to reduce the overall exposure that we have on the minerals markets. And that's why we need to reduce this dependency on external raw materials that are coming from all over the world by becoming more self-sufficient, or at least as self-sufficient as possible. And this we can achieve by going into recycling. And the good thing is, if you look into batteries, batteries are very, very well suited for recycling, because nearly all materials in a battery are recyclable, and 99% of the metals containing in the batteries are recyclable. So that allows us really to create this ecosystem and bring the metals back. At the same time, the EU already created the EU battery regulation. Even before we had the battery market, we already have a regulation in Europe that tells us and tells the battery producers what to do and how to do it, and what kind of recycling rates they need. So that already pushed the whole industry into one direction. And that's why in Europe we are having a big push towards development of new processes and also implementation of processes that have been already implemented on other places in the world, especially also in India, where we see a lot of innovation in the recycling market for batteries, as well as in China, where the market is already at least 10 to 15 years ahead of the European market. So if you look into the technological overview that you have currently, you will see that you have the typical mechanical recycling and mechanical processing as one of the ways to recycle the batteries, where you go to shredding, screening, and density-based separation of the battery components, and where in the end you're going to afford a very clean and nice black mass that you can sell back to the market. At the same time, you have some concurring processes like pyrometallurgy, where you have the high temperature smelting to recover the materials, especially the metals, cobalt and nickel and copper. However, this is a very robust process which has been established many, many years ago, and it works very well. However, the issue is in Europe, energy costs are very, very high. And the higher the energy costs, the less attractive this method is going to become. Then you can go and look further down, and you're going to go to hydrometallurgy. Hydrometallurgical processes are well established. You see nowadays that in China, most of the recyclers are going to hydrometallurgy, and where you go here you go to the chemical leaching and selective precipitation of the elements by solvent extraction of the materials. The big advantage in this technology is that you're going to have a very pure material with a very high quality, which you can then go sell downstream to the precursor producers and then produce new PCAM out of this material. There's now one movement coming up in Europe, which is pretty new and very interesting, and that is the direct recycling route, where you really take the material directly from the batteries and you repurpose this material in a way that it can be reused as is back into new batteries. However, this material has an advantage because the material retains its structure. It's a very cost-efficient route, energy-efficient route, and you don't have to go a further long way to recycle these materials. However, the point here is that you're going to have a few discussions on liabilities and also on how much can you actually use in a new battery or not. And now you are seeing from the coming from the university space and for really R&D labs, a new process which is bioleaching. In Europe, we now develop processes where you have microorganisms who are now dissolving the metals coming from the batteries and basically creating these metals again, but in a separate way. So you have nickel metal, cobalt metal, and lithium metal separated from each other, and the separation is done by this bacteria. It's quite interesting. It's a very eco-friendly process. However, it's still a very new process and only existent on a lab scale. So this is very, very new, but it's moving forward. But all of these technologies show us that recycling is currently a very vivid space and a very R&D heavy space where we need to develop new processes and utilize them here to become better in the future. So this helps all of us to move towards a more circular battery economy. For this to happen, we need to overcome a few key challenges. First, lithium currently is evenly distributed within the whole battery, so it makes it quite difficult to recover this lithium and getting back. Pyrometallurgy, as established as it is, it destroys the electrolytes and the binders and is very energy intensive, which is a problem. And then you have the trade-offs currently between high purity versus metal recovery efficiency. And the efficiency is given to us by the European regulation. Then we have to set some sort of R&D priorities because we need to improve the lithium extraction yields to reduce the overall chemical inputs that we need to have to produce new batteries. And then one thing that we're seeing, we need to adapt the whole recycling market to the new chemistries that are coming into the market, such as sodium-ion batteries. What's going to happen with those in the future? Or also solid-state batteries. How are we going to recycle these ones in the future? And then we need to get also the OEMs with us on one table to develop their batteries together with us. Because what we're seeing right now is the OEMs are developing the batteries for the cars, putting them in a way, but no one is thinking about recycling. And we need to design the batteries in a way that they are basically usable and reusable for recycling. And finally, because we are Europeans, we need to talk about policy and strategic outlooks. Because in Europe, we have the 2030 targets of above 95% recovery and recycling efficiency of cobalt, nickel, and copper. We need to recover at least 70% of the lithium, and we need to create a second life market for all of these batteries as well. And at the same time, we must not forget that lithium is going to become a more important factor in Europe to actually help us to move this green transition forward. So with all of these points together, we need to work together with you, with all the players in the market, to create a more circular battery economy, and this can only be done through R&D and collaboration all over the world together. So, yeah, thank you very much.
Thanks a lot, Philip, for that presentation. It was really enlightening. Next, I'd like to call upon Mr. Jared Zhu, who will talk a bit about the battery materials insights and forecasts. Mr. Jared Zhu, of course, is from SMM.
Good afternoon, ladies and gentlemen, and thanks for the warmly introduction. And this is Jared speaking from Shanghai Metals Market. And for someone who are not familiar with us, we are a China-based information provider and also well known as a price reporting agency. We cover ferrous, non-ferrous, and battery metals. And in China, our price is widely referred as a benchmark price, and also ex-China, and also we provide information, consulting, and events service by ourselves. So today's my speech will be divided into these 3 parts. Since my topic is more about the battery material, so firstly I would look into what's happening in the battery material market, and especially focus on the different chemistry. We are known as a LFP battery, and also NCM batteries will be more talked about in the first part. Second part will be more hold a future outlook onto the future trend on battery materials, since Philip has mentioned a few of it, like solid-state battery and sodium battery, and this certainly will to some extent change the total battery landscape. Last but not least would be a brief introduction of my company, SMM. So firstly, about the battery market overview. So this is our review and forecast of the key battery materials. This slide is talking about the LFP batteries for the EV usage. So, and also from top to down, you can see the price of the cathode material, the separator, the anode, and also the electrolyte, which is the 4 major battery materials composed in the LFP battery. And this does not only include the price review, but our forecast of the price of the key battery materials. So generally, and also this China-based price. From this slide, we can clearly see that currently there is clear oversupply situation, which means the supply definitely exceeds the demand. So you will generally see the price are stabilized. And to look at them one by one, we can see that firstly about the cathode price. So for example, the LFP cathode is mainly composed of the precursor and the lithium carbonate. And we both know for the lithium carbonate price, there was a big fluctuations back to 2022 to 2024. But after that, we see the lithium carbonate price remains relatively stable, and we see the general stabilized cathode material as well. And for the anode price, we can generally see the only fluctuations in the 2024 Q1 was caused by the feedstock fluctuations. We clearly see a increase in the feedstock cost, which is needle coke of the anode material in Q1, which drives the anode price upwards a little bit. But after that, we generally see also a clear stabilized price of the anode material. And likewise, for the electrolyte and separator, the price remains stable in the total LFP battery. And also, if we look at the NCM batteries, actually the market share, if we look at the EV market, actually in China, currently the latest data is like over 80% of the EVs are adopting actually is LFP battery because of its cost efficiency and high safety performance. While for the NCM battery, still we see it many innovations like high voltage mid-nickel, which enables it of higher energy density, but also helps to control its cost because of not so high content of nickel. So generally, we see the biggest difference of NCM batteries versus the LFP lies in its cathode. So generally, we see the NCM batteries still, it's because it contains nickel, cobalt, and lithium. And because for the cobalt part, we definitely see the DRC, the Congo's policy of exporting definitely drives up the cobalt price. And for the nickel, which mainly affected by the feedstock in Indonesia, like the MHP in Indonesia market. So this kind of 3 key minerals within the NCM and its uncertainties definitely pose more difficulties for the supply chain management and controlling. But generally, we also see the NCM batteries will remain at relatively relatively stabilized future trend. So the past few slides would be more a summary of what's happening in the China market of LFP and NCM. And to talk about it further, we still see there is a structural supply surplus currently in the China market, while the government has been aware of its unsustainable competition and oversupply controlling of it. But in general, we see China market as a driving power for especially from the demand side for the EV adoption. We can see the penetration ratio of China market, of the EV market, almost reach 50%, which means every 10 newly sold cars, 5 of them will be the EVs. The second part would be more looking into the future trends of the battery materials. So firstly, it's about the all-solid-state batteries. All-solid-state battery is definitely regarded as a next-generation battery because of its higher energy density and also the safety issues, which it can have very good safety performance. So if we look at, to break down by different material chemistry, actually the biggest difference comes from the anode and the electrolyte part. So for the cathode, it still could be high nickel, which to enable its performance of higher energy density. And for the separator, it will not be used in the all-solid-state batteries. So the biggest difference comes from the anode and the electrolyte part, especially for the electrolyte part. The all-solid-state battery has actually replaced the liquid electrolyte within the traditional lithium battery. Instead, people tend to deploy the different solid-state electrolytes. For example, oxide polymer and sulfate. These 3 different technology routes. And that brings us a lot of challenges. Because when we talk about the all-solid-state batteries, actually the interface connections, there is no liquid, right? So the interface connections and how the lithium ion can be transferred from the cathode to the anode impose a lot of challenges for the all-solid-state battery makers, which will definitely be reflected on the circuit life and also the C rate performance. And also for the anode, because all-solid batteries, they provide a platform which can do a more aggressive battery material, which definitely has more energy density in it. So therefore, we see the new battery materials like silicon carbon anode, or today we are talking about the CVD, this type of silicon carbon anode. And also, if we look into a longer future, the lithium metal anode will also be considered, which have even higher energy density and in the all-solid-state batteries. So from this side, we can clearly see that, especially for the all-solid-state batteries, which has the most aggressive roadmap, which will potentially deploy the lithium metal anode, could potentially drive the demand for the lithium metal as well. And also the cathode material, which deploys the high nickel content, also from this perspective will somehow also drive the demand for the nickel material as well. So how we see the global market size of the all-solid-state battery? So we want to put the all-solid-state battery market share within the total lithium battery share. So from the left part, we can clearly see the market size of global lithium battery demand. So still, we could see a very rapid compound annual growth ratio, which is more driven by the EVs, energy storage, and the consumable electronics. So it's the CAGR ratio from 2024 to 2035. Although in the EV part, we clearly see a relatively slowing down of the speed, but still it's growing, and mainly driven by the China and the European market. While for the energy storage, we consider it will have even higher potential of growth ratio because of the clean energy transition and energy storage system as a very key infrastructure to sustain this kind of transition. And also the more profitability comes from the energy storage part. Last but not least, we see the consumable electronics demand of like especially LCO battery will still have a steady growth. So how we see the all-solid-state batteries share within the whole battery globally, we can definitely see that it will not happen so fast. In 2030, we see all-solid-state battery, which means no liquid, to make it clear that the semi-solid-state battery is not included into this calculation. So we generally see in 2030, there will be roughly 4.2% of the all-solid-state battery within the total market share of global lithium battery demand. And in 2035, that number will grow to nearly 10%. So still it's a long way to go for the all-solid-state battery. And also sodium-ion battery. This is the idea, very idea that people brought up when the lithium price was extremely high. So sodium battery was considered as a weapon to combat the extreme high lithium price, and also a very cost-efficient solution for the power market and also for the energy storage market. While for the material of the sodium-ion battery, we can clearly see there are different technology routes. There is one called layered oxide, which is comparatively has higher energy density. So if we, the solutions like CATL's freeway battery, actually that kind of battery of the sodium-ion, which has been very focused on this energy density into the entry level of the EV, could potentially adopting this layered oxide technology route. Next would be polyanion. Polyanion will have higher circuit life, which essentially people regard it as a higher potential in the energy storage part. And nowadays in China, the government is actually encouraging the diversified portfolio of the battery technology instead of like 100% from lithium-ion battery because of its safety issues. So therefore, driven by the policy, we see a potential of the polyanion in the energy storage market as well. Last but not least would be the technology route of Prussian blue in the cathode. But for this kind of technology route, we definitely see the technical difficulties and also the toxic gas during the production still imposed in front of the manufacturers and which need to be solved. And for the anode, people nowadays more tend to use hard carbon, which can be further divided into biomass, resin, or fossil fuel. And in China, the biomass definitely accounts for over 80% of the total technology routes in the hard carbon anode solution. About the electrolyte, actually it can be synergized with the current lithium battery electrolyte, which is the sodium PF6 instead of LiPF6. Yeah. So that's pretty much what I want to talk about today. And last but not least, about a brief introduction of our company. So our company is called Shanghai Metals Market, and we will very focus on the metals market, and we extend to the downstream applications like battery material and battery, and also downstream applications. Our company has nearly 25 years of history, and nowadays we are not only focusing in China, but also expand to ex-China market. We are also serving Indian clients like Agratas and Tata Motors in the EV sector as well. And regarding what we provide industry data. We have a very comprehensive database compiling the market supply, demand, cost curve, the future planning of the production, this kind of market data, and also the regular report, which is weekly, monthly, and annual report, and also events and marketing, and also consulting, which to solve our clients' very customized requirements. Yeah, this is we are not very much like McKinsey, but we very specialized in the specific market research like ferrous, non-ferrous, and battery market. So we combine our market know-how and consulting methodologies to serve our consulting clients. Yeah, since my time is limited, so that will be my whole presentation regarding the battery materials. If you guys want to know more about no matter from the upstream mining sectors, metals, refining, battery material, battery technology, downstream applications, and battery recyclings, we are happy to talk. So thanks for your attention. Yeah, thank you.
Thank you, Jared, for that presentation. So while we've been on the topic of lithium-ion batteries and battery materials, I wanted to take some time to get into a broader category of what are called critical minerals. Lithium, nickel, cobalt are all part of this category of critical minerals. And so I wanted to just give a brief presentation on that, and then we'll head to the panel discussion. So I represent Loham. Loham is India's largest critical minerals company. Now, and the topic for this is what are critical minerals and why are they important? Why does everyone want these critical minerals? So if you look at broadly the kind of materials that are called critical, you'll find things like lithium, nickel, cobalt, platinum group metals, rare earths, copper, graphite, gallium, and a bunch of these things. These are all used in different kinds of industries. And all of these are industries that are critical from a perspective of the next half century. Overall, if you look at the battery material or the critical materials market, it's projected to be around $800 billion by 2030. But more importantly, there are almost 30 to 40% of global GDP is very critically dependent on these minerals. Today, a lot of the refining capacity is in China, and that's where a lot of countries are trying to develop capabilities to process the material. I'll give some examples here. If you look at a fighter jet, so India has been trying to develop its own fighter jet for a while. One of the key bottlenecks there is availability of material. So if you look at a fighter jet, it's essentially a series of material science problems. You have the jet engine, which requires a nickel alloy, high purity nickel alloy with chromium, cobalt, and whatnot. It also requires platinum and palladium, in fact. The airframes, again, are either nickel chromium alloys or titanium lithium alloys or aluminum alloys. And then radars and avionics, of course, require a lot of gallium, neodymium, and all the different kinds of technology materials. Just to give you a data point, a single jet can consume up to 500 kgs of rare earths, just rare earths, no other category of mineral. Similarly, if you look at industries of today and tomorrow, we talk a lot about green hydrogen and hydrogen electrolyzers. 1 gigawatt of green hydrogen electrolyzer capacity requires around 400 kgs of platinum and palladium. We talk a lot about wind. 1 gigawatt of wind capacity requires almost 200 tons of rare earths. This is in addition to all the nickel and cobalt and copper that is required here. Similarly, semiconductors require silicon, gallium, germanium, indium. All of these are critical minerals. Now, I'll give you a case study. Why are these things considered critical? If you see the picture on the left, it's a picture of a mine called Spruce Pine. This is in North Carolina in the US. This is the only mine in the world that there's a mine in the world that produces 90% of world's high purity quartz. Now, why is it important and why is it critical? If you look at the picture on the right, you'll see some crucibles. These crucibles are made of high purity quartz. The property of this crucible is that even at a very high temperature, this crucible remains chemically inert, which means that all the silicon that goes into almost every electronic in the world is melted in those crucibles. Every single device in the world has silicon that has been melted in one of those crucibles to make basically monosilicon crystals. which means that if anything happens to the mine, every single thing in the world will get more expensive. So you realize why some of these minerals are very, very critical. Of course, there is a criticality aspect, but there's also an aspect of economics involved over here. There is a growing market across all the different categories, and this is from IEA, the International Energy Agency, but this is again a bit conservative, I would say. There would probably be higher growth in some of these mineral categories. Now, I talked initially about how China has almost 90% of world's critical minerals capability. It's not happened overnight. There's been a very sustained and systematic strategy to get there. And it started more than 50 years ago. So the groundwork was laid almost in the 1970s when R&D began. In the 1980s, mineral resources laws came in, mining rights got centralized. In 1990s, we're talking about more than 30 years ago, critical minerals or strategic minerals as a category was identified. And so we should basically admire the foresight that a lot of policymakers in China had. And even back then, China has started to put export controls. 2000s, when China entered the WTO, a lot of environmental rules kicked in, compliances became stringent, consolidation started to happen. A lot of the large companies that we see today started to emerge. 2010s is when global mining asset acquisition started to happen, subsidies started to be given out. And 2020s is when China has truly come into its own. You have national champions, export bans, domestic exploration happening. Over the last 20 years, China would have invested more than $100 billion across these different categories. And this is something we should learn. What we should also learn is to learn from Chinese companies. Across these different categories, there are multiple multi-billion-dollar companies that have emerged. So there's clearly a lot of opportunities over here across categories of these critical minerals. And now the world is trying to catch up. China has done a lot of the hard work already, but now people are realizing that there is an opportunity not just from a strategic point of view, but also from an economic point of view. So you see a new headline every day because of this. India, of course, is not far behind. India has taken up critical minerals as a national priority, starting from 2019 when Kabil was established as a joint venture between three public sector organizations, NALCO, HCL and MECL. Kabil has the mandate to go out and acquire mines across the world. You have the battery waste management rules that came in 2022, similarly the e-waste management rules that came in again 2022. These streamline the recycling industry to ensure that critical minerals get recycled in the country. You have then critical minerals, official designation of critical minerals that came in. You have the Mineral Security Partnership. You have auction blocks for mines happening. India is also now exploring offshore mining and deep sea mining of polymetallic nodules to get these minerals. In 2024, the National Critical Minerals Mission was announced. And in 2025, a budget allocation was done to it. In the national, for critical minerals, almost in June 2023, 30 minerals were identified. The criteria was either economic importance or supply risk. Sorry. In August 2023, 24 of these were essentially made legally put down as in the list of critical and strategic minerals under the Mines and Minerals Development Regulation Act. There was an amendment made to it in the parliament. If you look at the periodic table, these are the minerals essentially covered under this. A lot of these minerals were earlier very strictly regulated by the Department of Atomic Energy, and they were deregulated because the government wanted the private sector to come in and start processing the minerals. In the National Critical Minerals Mission, almost $4 billion of capital has been allocated. There are very strong targets that the government has set up. The government wants to go overseas and acquire 50 mines. Within India, the government wants to have at least 1,200 different kinds of critical minerals, 1,200 different critical minerals projects to be set up across the value chain, from recycling to processing to everything. Apart from this, there are global partnerships that are emerging. So you have the trust partnership between US and India. You have the TSI between India and UK. There's a special working group that has been set up for this between EU and India. And then there is the Quad, where India, US, Australia, and Japan are working together to acquire this. And then there's the Mineral Security Partnership, where 13 countries have come together to essentially set up projects across the globe for this. Under the Critical Minerals Mission, if you double click on it, you'll see that the capital allocation has been done for everything from R&D to exploration to recycling. In fact, the recycling scheme is going to come out very soon. Almost 1,500 crores of rupees, which is around $170–180 million have been allocated for this, for promoting recycling of critical minerals. There are also allocations for R&D, for stockpiling, and a bunch of other things. Of course, India is not the only country, so there are other countries that have focused on this as well. You have policies, again, all of these policies have come out very recently in most of the places that have declared, all countries have declared their own set of critical minerals, US, EU, Japan, Australia, Canada, South Korea, and this is by no means exhaustive. There are a bunch of countries have their own list. Most of these are overlapping, but there are some differences here and there as well. Now, I like to end this with a small story. I talked about spruce pine and how there can be bottlenecks because of critical minerals. There's a story of one such bottleneck. So if you look at the magnet industry till about 1970s, it was dominated by what's called the SMC, or samarium cobalt magnets. But supply chains were weak and uncertain, because of which a lot of Japanese emerging electronics companies were struggling. So there was one gentleman called Masato Sagawa who was working at Sumitomo Specialty Metals. What he did was he tried tens of different kinds of critical minerals and rare earth formulations, and he came up with what's called the neodymium magnet, which we use everywhere. If you have a phone or a laptop, or if you travel in a vehicle or a car, all of these are powered by these magnets, the motors, the speakers. And what happened next is essentially the magnet industry took off. These magnets were cheaper by an order of magnitude compared to previous magnets. And by 2000s, Japan had almost 90% market share in the magnet industry. Of course, the world has changed now, and the market, and it's after that rare earths became a sort of geopolitical issue. But I tell this story mainly to highlight the fact that access to these resources is very important, and also the fact that just because the market is concentrated today, it cannot change. It's happened in the past, and that's something that all of us from across the industry and across geographies, different markets, all of us who are here should try to take lesson from and basically grow the industry. Thank you, everyone. We'll now have a panel discussion after this. We'll focus on battery recycling. We'll also talk a bit about lead-acid battery recycling, from where a lot of lithium-ion batteries come in. And I'll be moderating the session with all the great panelists over here. Thank you, everyone. So, the topic for the panel discussion today, we had a couple of presentations on batteries, and we would like to now dive deeper. I'm sure audience would have a lot of questions, so please hold those questions. We'll have some time at the end to discuss those. But before we start, I think I would like all the panelists to maybe introduce themselves and maybe give a short opening remark. So I'd like to start with Vinayji. Vinayji, please start.
Hello. Yeah, I'm Vinay Sharma. I'm heading GDB International. We are suppliers of various kind of non-ferrous, including lead from USA, and we have a processing units as well. Thank you.
Yeah. This is Jared speaking from Shanghai Metals Market, and the consulting manager from SMM. And we are a price reporting agency, and also we provide service of data, consulting, and also reports.
Hi, I'm Felipe. I'm the managing director of Revomet, and we are a battery recycling company from Germany.
Thank you. This is Pavadeep. I represent Atero. We are into electronic waste recycling and lithium-ion battery recycling with the aspect of sustainability and circularity what we focus on. Thanks.
Thank you, everyone. We'll have questions around policy compliance, sourcing, and then in general about formalizing a lot of the market. I hope by the end of it, you'll be more educated about the battery industry and you'll have some insights and takeaways from here. My first question is to Vinayji, and I'll have the same question for Mr. Pavandeep as well after this. But India introduced the battery waste management rules in 2022. In 2025, there were some additions to it for tracking and traceability. How are these policy changes helping you?
Quoting your presentation, Pratyushji, I saw how to save the critical metals. So the policy was introduced in 2022, and there was some amendment came. And these amendments are much needed amendments, which requires the traceability, which requires the international EPR, it requires the lot of stuff which were missing in the earlier policy. So the mandatory publish of the QR code, which can be traced by, it is mandatory in this law. That's the most important thing, because if we cannot trace our material, if we cannot trace our product, it is very difficult for all the producers to get their product back to the source. I'll be quoting the same example because Japan have, very high standards, So one of my clients is here also as well. They have the aluminum wheel, which is coming from Toyota. And they make sure that wheel is being sent back to the Toyota with the same compliances, same quality, which, Toyota makes. So a bigger company like Exide, if gets that battery again to its system, that's again, you can get the good quality, you can get the, their material back. And there are a lot of other things which can be done with this. We can detail, talk on this.
Pavanji.
So basically the rules came in 2022 and further there were additions to the rule in 2024. The concept of these rules are more related to the extended producer responsibility, where the producer is liable to make sure the batteries go into a system where they are fully tracked, traced, and moves into a circular, sustainable aspect of recycling. Further in the rules, there are targets related to incorporating recycled metals in your supply chain, which is critically important. And that is the aspect which the government and these rules cater to, that the product which is incorporated in the batteries, these metals should be recycled in proper environment friendly manner and they do not land into the landfill. So that's why a complete tracking and traceability mechanism has been worked out over there. Thank you.
Thanks a lot. So, clearly the rules in India are helping to some extent, but we'll also like to talk and have a look at the international sort of angle to it. So maybe Philip, we'll start with EU and how the policies have helped there. And Jared, then we'd like to understand about China and the rest of Asia, how policies have impacted battery recycling.
Yeah, so in the EU, it's quite a mixed picture, as always, because the regulation on one side is helping us to create a recycling ecosystem for all the mechanical processes that we need in Europe to collect the batteries and treat the batteries in Europe and have this recycling efficiency that's necessary. However, at the same time, currently we don't have hydrometallurgical processes in Europe, but all materials coming from recycling are hazardous waste. And all of this hazardous waste that we get from recycling, we need to bring somewhere for it to be further processed, because all of these metals need to be recovered. And for this to happen, currently the only existing markets are OECD countries. And from these existing markets, there is one country, that's South Korea, that's the only one which has enough capacity. So we are closing the markets on one, we're forcing the market to recycle on one side, but on the other side, we're closing the market down to really regain the batteries. So we are helping companies exist, but then we're throwing sticks between their legs so that they cannot really continue doing their business, because it's almost impossible to sell the material to the further refiners. Yeah? And to get a hydrometallurgical plant in Europe, just the bureaucracy behind this is so big that it takes so much time that by that time I think China will have a completely new industry set up just for recycling of these materials.
Jared.
Yeah, I will talk more about China market. So when talking about China market, people tend to talk about two very representative policies. One is called the whitelist policies. So likewise, people may regard it as a threshold or as a certificate to say whether you can do or not allowed to do recycling in China, but it turns out not to be compulsory, which means people don't have to have the whitelist certificate to do the recycling in China. So therefore, that has led to many recyclers into the China market. So nowadays, we see generally very low utilization ratio of the capacity because of the very oversupply scenario. While we do see that it's getting better because we don't see many new entrants these days, and that would be definitely more merger and acquisition in this field. So I would say the policy, they may, in this perspective, they're somehow lagging behind the actual market development. But at the end of the day, to somehow to control such chaos, I would say the policy will catch up. So that's the first policy. The second policy would be more related to the black mass imports. China used to tend to regard the black mass, which is the shredding product of the battery scrap, as a waste. So therefore, based on this logic that China used to not allow the import of the black mass. But I think just in these months, the customs or the trade department in China has opened up the import from the overseas countries into China. So I think that reflects a signal that the policy side would more regard it as a resource because it contains nickel, cobalt, and lithium, which is also listed as critical minerals in China, instead of the waste. This kind of logic has been changed. But that would help to increase the import of the feedstock, which will help to ease the overcapacity scenario. But my personal opinion would be that will not help too much because, as Philip has mentioned, Europeans has also more strict on the exporting of the waste to only the OECD countries. So in this perspective, I would say how could you get from the overseas countries to China is still pose a problem. So that's we still should hold a more active or more dynamic attitude towards it. But generally, we do see the policies still in China, especially for the recycling market. I would say the market step first, but eventually, I think the policy will catch up. Yeah.
That was a very good insight, the policy lagging the market realities. And a related question, I'll again start with Jared and then maybe we can move across the table because it's common to everyone. How do you see the availability of feedstock in China today? You mentioned that there's low utilization. And how do you see it evolve over the next 5 years? Do you think there will be sufficient volume?
Yeah, because we also, when we're talking about lithium battery recycling, we talk from the perspective of sourcing, technology, cost, business model. And I always talk to my clients that sourcing is the most important part regarding the key success factor because that has very related to your cost efficiency, economies of scale, and also the business model that you can play. So when we talk about the sourcing feedstock, it generally can be divided into 3 parts. So besides the import, which just happened recently, there will be generally 2 parts in China. One is production waste. Production waste means something generated from mainly the company like CATL, BYD, EVE, like this kind of battery manufacturer. So there's some unqualified like battery tablets, pole pieces, or unqualified battery cells. This is definitely which is driving the development of the recycling market. Account for over 50% of the battery scrap tab would be coming from the production waste. While when we say the lithium battery recycling is promising because we do see a very high potential of end-of-life battery. But end-of-life battery takes time. Because nowadays still you can see the newly sales EV still is growing very rapidly, and it takes time, like roughly like 5 to 10 years to wait to be retired. So that part currently is actually not taking the dominant share regarding the total battery scrap that can be sourced. So that's a general picture. So if we deep dive look into different companies, I would say in China we have the biggest or the most leading companies are the integrated ones, like Huayou, like GM, like Rump. The business model actually they are playing is like they have the battery shredding to the black mass, and also to refining to the nickel sulfate, cobalt sulfate, lithium carbonate, and then to further refining into battery material, which is precursor and cathode. So they have very integrated value chain. So in this case, what the service that they can provide to their customers is more diverse and comprehensive. For example, we assume that the battery scrap resource is actually owned by the battery manufacturers nowadays because of the production waste logic. So therefore, we see this kind of model can, for example, this integrated battery recycling companies from the recycling into the final, let's say, Brump and GM, they can manufacture the cathode. Therefore, for the battery scrap resource owner, which is the battery manufacturer, that's binding with this type of recyclers can help them to build the closed loop, and therefore the traceability of it. So I would say this is the type of the company we see currently in the China market, which has the highest potential of getting more battery scrap and to play a leading role in this market. Yeah, that's my understanding of the sourcing. Yeah.
Got it. Philip, how are you seeing the sourcing in the European market?
So currently in Europe, you are going to have, I think the latest numbers show that until 2030, you're going to have basically overcapacity of recycling in the market. That's going to change by 2030. That's what's expected. So currently, there is availability in the market of materials. It's mostly scraps, battery scraps from production, but not at the same level as in China. The installed gigawatt production capacity in Europe is, I don't know, it's far less than China. It's not even worth mentioning compared to China. So the overall amount of waste is very low. However, it's enough to sustain the size of the industry that we have right now. But we're already seeing the first recyclers struggling because they over-invested, brought up too much capacity to the market too early and started overpaying to fill that capacity. That has brought a negative dynamic into the market. And with this negative dynamic, you change the market from a recyclers market to a waste producers market, basically, where the waste producer now can choose who it's going to. And we had a situation, I think it was 3 years ago, we just talked about it, where batteries had a negative price, right? So you had to pay an entrance fee, a gate fee to get into the recyclers. Nowadays, that has changed. So recyclers are now competing against each other to get these materials. But there are still materials available. There are enough recyclers that can survive at this level. But it will all come down to the efficiency of your process and basically how lean you are as a company. Because if you are now starting to overinvest with large headcounts and big capacities, you're going to struggle because you cannot sustain this. So you have to grow organically with the market, but you have to bear in mind that this is going to be fast because by 2030 we're going to see this overlap, because we also expect by 2030 not just the battery scraps to be in the market and more gigawatts production to be installed in Europe, but also the first end-of-life batteries are now coming, because we started 2018, 2019, and looking at those generation of batteries, they had a lifespan of 10 years roughly. So this is when we're going to see them coming back. And we expect them, because it's mostly NCM based, not to go to second life applications due to the fire hazard and all those other related topics, but more directly to recycling. So this is when we are going to expect the market really to turn and to become where recycling is going to become a scarcity and material is going to be readily available. But we all need to survive until this point, and we need to be competitive up until this point.
Thank you. That was a great insight. Pawanji, you can shed some light on the Indian market.
So as far the Indian ecosystem goes, the ecosystem is still being developed. If you foresee, there are recyclers, but there are no gigafactories. There is still the ecosystem for cell manufacturing being worked out with the PLI schemes and the other incentives which the government has started giving. If we look at the aspect of consumer durable batteries, those are abundant in number. But if you look the aspect of chemistries being utilized in India, there is more inclination towards the LFP chemistry. So the facilities which are there, and with the inroads of the gigafactories coming into the country, I feel there is still time for the recycling capacities to be increased in the due course of time. They would not have the ample amount of feedstock to refine. Whereas what I feel in India, it is more of a trading market for the black mass which is happening. And the black mass as a commodity is being traded across India and moving out of the country, which has now been tried to be restricted by the government and to be refined locally over there. So my perspective would be, it is still the ecosystem is far away and it would take time to be developed in India. Thank you.
Vinayji, so we talked a lot about lithium-ion batteries. How do you see the lead-acid battery industry developing, and particularly from a sourcing point of view?
So, like Philip said, so what India has a big problem of unorganized market. So this new law has been implemented just to see that this comes back to this original source. So we are in short of material, the local recyclers, just because the unorganized market is a big time in India. We have recycling companies who are actually exporting, importing, and doing a quality product. But India has abundance of, I'm not talking about the lithium ion because we are very new. China is big, But in the lead acid battery, we have sufficient stock, domestic stocks, which can be utilized if it's traced back to the source. If it is there, so there are certain laws, there are certain taxation, there are certain policies which has to be amended, and they're doing it. And once it's done, India will be able to use its own material back to the source, back to the security, back to whatever, because India is import driven. We are already dependent upon the imports. Still the local material is not reaching the factory. But soon, by these laws, hopefully we'll get the material.
Thank you. I've been told that we are running out of time, so we'll not have any more questions from me, but we can take one final question from the audience if anyone has a question.
Hi, my name is Vaidyanathan. I'm from Pondy Oxides and Chemicals from Chennai. One thing that I would like to ask Mr. Pawandeep Singh, that he said, the feedstock, the ecosystem is still not there for lithium-ion batteries, and also the collection of LFP batteries is a problem, and there is a feedstock problem still there whenever it comes to lithium recycling. I would want to understand, there are so many lithium-ion plants now coming up in India. under what circumstances or under what belief that they are all coming out with such plans, and how are they sure that they will get the material, the feedstock? I just want to understand this. I'm really surprised there are so many plants coming up, and from where they will get the feedstock is something that, because even the government on EV sector, the subsidies are going down. It's not like before, like slowly the government is also playing down on the subsidies that they are offering in the EV vehicles also. So just want to understand this, yeah.
So thank you, and I'll just clarify. My point was that the LFP is one of the more taken up chemistry in India. So the black mass which would be there would be of LFP. As I stated, that the ecosystem is not there. What do I mean by the ecosystem? There are multiple cycles, as Jardin also stated, in China. It is from the start where the manufacturing happens, the production waste comes. Production waste, if we talk about at the initial stages of 5 years, a company produces almost 30 to 50% of waste as production waste, a gigafactory, which becomes the ample feedstock for any of the recycler. As on date in India, there is nothing of that similar nature. Talking about multiple plants coming in, yes, the PLI schemes have been given in India. There are multiple plants which would be set up. The complete ecosystem has to be developed. I'm not talking about only the productions which has to be there. There has to be pre-chem, there has to be anode manufacturers. So the complete entire ecosystem from copper foils, aluminum foils to electrolyte or cell casings, each and everything has to be there. Then only a complete entire ecosystem can be developed, and the recycling facilities would have the ample feedstock to fulfill their capacities. All the facilities which are coming in on the projection that they will be able to import the material and subsequently recycle in India. The capacity in India is not currently to the stage where it could fulfill these capacities. Thank you.
Thank you.
Thank you, everyone. So we had an enriching session. I'll just summarize the key insights for everyone. So I think in the beginning we talked about India, where the policies have been helping grow the market. One of the issues that's a sticking point is one around quality of the material that is being produced, and two is around the informal sector from where the material is coming. How do we formalize that? In Europe, we found that the policies are basically both helping and hindering the growth of the industry, helping set up a lot of recyclers, but when it comes to growth, the availability of downstream players is low, and the number of countries where the material can go is limited. In China, we looked at the whitelisting policies where, although they are there, but there's been a lot of players and there's low utilization today, which means there's a lot of consolidation happening in the industry. The Chinese government has also changed its view on black mass, and it now treating scrap and black mass as a resource instead of as a waste. And I think that's a very important point that both Europe and India can learn from, because we've not thought along those lines yet, and China is ahead of us in any case. Overall, I think there was a point around in terms of supply. Of course, China has a lot of production waste, which India doesn't at this point, and Europe has, but at a smaller scale. Most of the feedstock today is from production waste, which means, as Mr. Pawan said, during the manufacturing of lithium-ion batteries, in the first year or two, almost 30 to 50% of the material gets wasted, and that is what is coming as feedstock for recycling in China, to a smaller extent in Europe, and will come to India. Once that starts happening, there will probably be demand for more capacity in India. But overall, I think the sentiment is that there is overcapacity, at least at a shredding level, across the geography, but downstream ecosystem needs to be developed, at least in Europe and India. And LFP is something that needs to be thought about, because the economics around LFP are not yet fully worked out, and that's something that will need to be done, because LFP is going to be the most dominant chemistry. Thank you everyone for coming. I hope you enjoyed the event, enjoyed the session, and all of us can take questions offline after the event. Now, before we go, I think there's some memento that the MRAI team would like to give to all the panelists.
I'll smile, I know what it takes to fool this town. I'll do it till the sun goes down and all through the night time. Oh yeah, I'll tell you what you wanna hear. Keep my sunglasses on while I shed a tear. It's never the right time. Yeah.